Okay, hi, Assalamualaikum and very good day everyone. So today we'll cover the last part of chapter 5. So on the first, second and third part we already covered on the Titrimetric Method overview, acid-base titration, and what is the endpoint, how to calculate the equivalent point, how to sketch the curve based on the acid-base reaction. And now at part 4 we'll learn on the precipitation reaction. So first of all, what is precipitation? Precipitation is the formation of a solid in a solution. So the solid form is called a precipitate. So for instance, reaction of KCl with the silver nitrate, and the silver nitrate is a precipitating agent and produce the precipitate, which is the silver chloride. Okay, so the properties to perform the precipitation, the precipitate must be solubility of compound must be insoluble form. So for instance, the silver chloride slightly dissolved in water. So the silver chloride has a specific solubility. So previously on the part 2 and part 3, we learned on the constant acid and constant base, which are Ka and Kb. So in this precipitation, we learn on the solubility product constant, which is Ksp, constant solubility product, Ksp. Okay, so Ka for constant acid, Kb for constant base, while the Ksp is the constant solubility product. Okay, for the precipitation titration is a titration method based on the formation of precipitate, which is slightly soluble, and titration with precipitating agent is useful for determining certain analytes, provided the equilibrium will take place rapidly and suitable means of detecting equivalent point is available. And at the end of the reaction, you must be able to plot the curve. Okay, before we plot the curve, we must identify, similar as acid-base reaction, we must identify at least 4 points, which are before titration started, equivalent point, and finally excess of the titrant. As an example, titration curve for a single anion, calculate the PAG, the P value for the silver of the solution during the titration of 50 ml of 0.05 molar sodium chloride with 0.1 molar silver nitrate. So after the addition of the following volumes, which are 0 ml, 24.5 ml, 25 and 25.5 ml. Okay, so first of all, I suggested to you to perform the equivalent point. So how to do that? So first of all, do the stoichiometry reaction. balance it, and you may find that the equivalent point is at 25 mil. Okay, first, before the titration started, where the titrant is 0, so therefore the PAG is indeterminate. So next, before the equivalent point, okay, the KSP for silver chloride is 1.82 times 10 power of negative 10. So at equivalent point, and last, post equivalent point. So all the points that have been calculated may plot on the titration curve. So P value or the PAG versus the volume of the titrant. Okay, so how if there are mixtures anions? So these are the example. So calculate the PAG of the solution during the titration of 50 ml of a solution that is 0.05 molar iodide ion and 0.08 molar chloride ion with 0.1 molar silver nitrate. So after the addition of the following volumes of reagent, 0, 24.5, 25 and 50.5 ml. Okay. So basically in this case, we will see they have two equivalent points. So first, with a reaction with one anion, and the second with another anion. Okay. So first of all, we will perform the stoichiometry reaction. So from the stoichiometry reaction, we may see that the first equivalent point reached at 25 mil, and the second reaction reached at 40 mil. Okay, so in this case, we may see that the reaction may complete at the first 25 mil, where at 25 mil, the reaction between the AG and the iodide ion, while at the next 40 mil, it reacts with the chloride ion. Okay, therefore the first equivalent point is at 25 mil, and the second equivalent point is 25, which already in the flask, at another 40 mil, which make the reaction complete with the chloride ion. Therefore second equivalent point is 65 mil. Okay, so first, before the reaction, indeterminate, 0 mil. Next is before first equivalent point, which is 24.5, where 25 is the equivalent point for the first reaction. Okay, so the equivalent point for the first reaction, AGI, where the KSP for AGI is 8.3 times 10 power of negative 17. So next is the post equivalent point for the first reaction, but it is pre-equivalent for the second reaction, where here the KSP for AgCl is 1.82 times 10 power of negative 10. Okay, so these are the titration curve for the reaction of one anion. Okay, for the mixtures anions, it's supposed to have two stages, which consists of two equivalent points. So the first one at 25 mil, and the second one is at 65 mil. Okay. Okay. So this is the exercise for the precipitation reaction. So calculate the PCl for the titration of 100 ml 0.1 molar sodium chloride with 0.1 molar silver nitrate for the addition of 0, 20, 99, 99.5, 100 and 110 AgNO3. So the KSP of AgCl is 1.82 times 10 power of negative 10. So please try it. Okay, so we already know how to determine the endpoint for acid-base reaction, right? So we use the indicator. So basically, same goes to the precipitation titration. We use the indicator. So in the precipitation titration, they have a few methods. So the first one under chemical. So for the chemical itself, they have three types. So the first one, Morse method, Fajan's method, and Volhard method. And a part of the chemical, they can use the sensors such as potentiometer or amperometric. So for the acid-base reaction, we may use the pH meter. Okay, so what is the differences of these three types of chemical detection? So the first one, Morse method, it is a direct titration. So the basis of endpoint, formation of a colored and precipitate. So the indicator is a soluble chromate salt. While the Volhard method used as a procedure for titrating the silver. Okay. And the last one is the Fajan method, known also as an adsorption method. Okay, so now we reach the end of the chapter 5. So please answer this assessment. All the best. Bye.